Welcome to Chapter 4. Today's section we talk about midpoint and slope. This is really a transition section from what we did in the first quarter with proofs and what we're going to do in the second quarter, which is more algebra-based stuff. So our first concept is called midpoint, and we've already talked about midpoint in proofs and what it does to a segment, that it bisects it, but we never talked about how to calculate it. Well, the way to calculate a midpoint is to use this formula, x1 plus x2 over 2. So basically you're taking the two coordinates and averaging them, and do the same thing with your y coordinates, y1 plus y2 divided by 2. Average your coordinates and you get your midpoint. So our first example, we have CW is a diameter of a circle, and a diameter is a segment that's going to go from one point to the other all the way through the center of the circle. So if I want to find the coordinates of O, which is the center of the circle, I'm going to find the midpoint of this segment. So to do that, I'm going to take my x coordinates, so I'm going to take -3, add 1, and I'm going to divide that by 2. And I'm going to take my y coordinates, -1 plus 3, and divide that by 2. So -3 plus 1 is going to give me -2. When I divide that by 2, I get -1. -1 plus 3 is 2. Divide that by 2, I get +1. Those are the coordinates of point O, which is the center of the circle, and also the midpoint of the diameter. We also have slope, and this should be a review from Algebra 1. The slope is often described as rise over run. How much should we change in the y coordinates over how much should we change in the x coordinates? So our formula for slope is y2 minus y1 over x2 minus x1. Subtract your y coordinates, and then subtract your x coordinates and divide those. The most common mistake you're going to make is you're going to flip-flop the x's and the y's. Be extremely careful with that. So as a quick example, we want to find the slope of the line containing 7, 5, and -3, 2. This is x1, this is y1, x2, and y2. So my slope formula says take my second y coordinate, subtract off my first y coordinate, and divide it by my first x coordinate minus, my second x coordinate minus my first. So 2 minus 5 is -3. -3 minus 7 is -10. Because these are both negative, I'm going to cancel that out. And I'm going to make it 3 over 10. So again, be very careful that you make sure that you're consistent with your order. With slope, we can get into a discussion about parallel lines and perpendicular lines. Parallel lines are lines that have the same slope. They will not intersect because they're going to rise and run at the same rate. Perpendicular lines are lines that will intersect, but they're going to intersect at right angles. And the way we calculate that in terms of slope is opposite reciprocal slopes. So as an example, if I had a slope of 2/3, my opposite reciprocal means I'm going to flip the fraction and change the sign. So -3/2. And for this example, our last one, we want to know if A is a right angle, and we want to justify our answer. In order for it to be a right angle, that means that these two lines have to be perpendicular. So I need to calculate two slopes. I need to calculate the slope of dA, which will be 5 minus 1 over 1 minus 4. So it's 4 over -3. And then I need to calculate the slope of AY. 5 minus 1 over 7 minus 4. +4 over 3. So if I look at my two slopes, they're very similar. They're opposites, but they are not reciprocals. I would have to take -4/3 and eventually get 3/4 to be an opposite reciprocal. So my answer is no, because the slopes of AY and AD are not opposite reciprocals. If it's asked for parallel, I would need to compare the two slopes and see that they were equal. But perpendicular, I'm looking for opposite reciprocals.